Good morning, everybody. Hey, everyone, Lazy Ben. Let's put the music on. Somewhat chill, somewhat lo-fi, right. Shorter week for me this week, only 3 days, because the kids break up from school on Thursday. I should change that on the back end of Twitch. Give me a sec. How do I even work this website? Schedule. Edit. We're going to say we're going to start at 10. I've got till 3 as well. I think I'll probably have to finish. We'll do a 4-hour stream. It's only 1:30. We'll do a 5-hour stream. No, we'll do a 4-hour stream. That's 10 till 2. That's... Thursday, actually, though, is probably going to have to skip. All right. So it's only a 3-day week this week, because the kids break up for school on Thursday, and I need to be a parent. All right. So we have 2 monorails going. So today, let's just look at the... Let's actually, before we start anything, look at the notes. So last week, we did start the monorail system. So we got all our goals done last week. This week, which is the 31st of March to the 4th of April. What are the goals for this week? Monorail system. Well, let's break it up a bit. Add monorail car movement. Add monorail stations. Allow player to travel the monorail. So I also want to add NPCs to travel the monorail. That's obviously a bit more work. So we'll have those 3 goals. I've got 1 a day. Could have a stretch goal maybe. To allow NPCs to travel the monorail. Maybe. Okay. So the first one is add monorail car movement. So we kind of half worked on this. It was the end of the week last week though. So I was a bit tired, so we didn't really do much. Okay, so where is... Okay, so I think what I'm going to do... I'm going to have to rewrite this because I was too tired on Thursday, and this is obviously not great code. So we have this thing called a step, which we multiply by the speed. So what I think I'm going to do is chuck all this like this, and then we do step, which is dt divided by the spline length. And then we have this thing called car brakes. So I think we're going to get rid of that. And then we're just going to say car speed so we're going to have float acceleration, and that can be deceleration as well. So we're just going to go car.speed plus equals car dot acceleration times dt times step. Then we're going to clamp it between 0 and 4. Yeah, we don't do step there. And then we're going to do r.speed times step. And that sets the current path if it gets to the end. All right. And we've got 2 monorail cars, and we've got 2 paths at the moment. So we'll put them on path 0 and path 1. They're on separate paths. Okay. So we've got 2 cars traveling along. So we're just going to put a station in here. So if you look at the notes again. Add monorail car movement, right? They're together, really. Well, monorail car movement depend on stations. Stations also includes all of the UI and stuff. So, I think all I'm going to do is put in a little circle there, and the car's going to slow down to it. wait for a few seconds, and then speed off. And any cars that come behind are going to have to slow down also, so they don't crash into the back. So, where are we drawing the monorails? We're going to say, we're just going to hard code the monorail station to be at halfway through. So station T equals 0.5. So the station is going to be halfway through the monorail spline. Let's just see, what room are we in? Game.config. We're in monorail station.room. So we're going to say if path.room ends with, do you have an ends with? No. Helpers string ends with path.room. So if we're in the monorail room, we're just going to go auto station P equals path.spline.getPoint for station T, and then we're going to go canvas draw circle outline in world station P. We'll give it a radius of 1 world unit. Okay, so that's just going to draw some bounds for a monorail station. Lee Oswald, hey, how's it going? What is CPP? C++, the language. Yeah. Sorry, I might have missed your message. I didn't have the chat open for a second. Alright. So that's where the monorail station is going to be. Let's just make it a bit bigger. Let's make it like 3. Okay, so that's the monorail station. So we basically need to slow the monorail down till it gets to there. So the distance we've got to travel is the radius. So what we're going to do is we're just going to say rect station bounds. It's not a rect. Rect to station P, and then we're just going to say call that station P, right? So if the distance between the car position do it here. If car dot position dot distance squared to the station P is less than so we want station radius, right? station R is 3. We need to be slowing down. So what I might do is I might just detect when we get into that circle, check that's working. So we're just going to make the cars, we're just going to add another colour on like that. So if it gets in within that station, it should change colour. Change colour too early though, because it's station R times station R. Doing the distance squared. All right, there we go. So we've got to work out the distance. Well, the distance is this. So D2 is that. So the velocity or the speed of the yeah, so we're going to go auto the ratio is equal to 1 minus D2 divided by station R times station R. And that is saturated. Like that. So as that gets closer, it's going to go to 0. So it might not be 1 minus. Well, we need it to go to 1 because we're going to so we need to say so that goes from that ratio decreases, so it goes from 0 to 1 like that. So the car speed, so say the max speed is is 4. Got to go car.speed equals bm lerp between 0 and car and 4, the ratio. I don't think we need the 1 minus there. Let's see what happens there. So they stop So I might just draw the car speed on the car. So get game HUD. Draw label in world. The label position is going to be the car.position. Let's draw it white. And the string just wants to be helpers format TW string car.speed. So let's temporarily include the game HUD. All right. So what we want to say is if car.speed is less than 0.05, car.speed equals 0. See what that looks like. Let's say 0.1, say 0.2. So it doesn't exactly stop in the middle doing that. They are drifting as well. So we might say so we're going to do this maybe. There. And then Taking them a long time to stop. Maybe that's not that great then. Maybe we do some kind of lerp when we do the lerp. So the ratio remains the same. So we need to actually lerp t, really. I would say. So it'd be car.t so we lerp car.t to 0.5. And what I'm going to do is I'm just going to go I'm going to say struct e monorail car state unknown, not struct, sorry, enum class unknown, and then we're going to say traveling approaching station, leaving station. Like that. And then we're going to say if car.t is less than station t, car.state is approaching station, else if car.t is greater than station t, car.state is equal to e-monorail car state leaving station, else we want at station. And then we're not going to do the speed stuff just yet, but we will draw the label. We will add to the label car state. Okay, so it's in the unknown state. Approaching station, leaving station. So if we're just doing it for this route, cars that are in this room right now. Else, we're just going to say car.state equals monorail car state traveling. Traveling, approaching station, leaving station, traveling. Okay. So now, based on the state, we can do this stuff. If car.state is monorail car state traveling, it's just this. Else, if car.state is monorail car state approaching station, then we need to work out how close they are to the station, right? So auto ratio equals car.position. If it's approaching the station, it's it's car.t minus 0.5 minus car.t, right? Divided by 0.5. Well, actually, we'll smooth step between the station P no, it needs to be in T. So when this first happens, hang on. When this first happens, let's just see what car T is. So it's at 0.47. Well, hang on, it might be inside the station. No. We need to know what the T value is of where the station intersects this line. So we need to know that value of T. Right. How do we get that? How would we even do that? That's interesting. So we know that radius so we basically need to follow the P back. Follow the, we've got compound lengths. Interesting. Well, we have it there because it's not adjusting the T. So the ratio equals car.t, so 0.5 minus car.t, right? Well, we want to do a smooth step, won't we? Smooth step between car.t and 0.5, or station t. So we want like basically a delta t here. So we want flow approach station approach t. Yep. So this is station approach t. That, and then the where do we work out the car's position? Here. So that's plus car.station approach t. So that goes from 0 to 1, which is not correct. So we're going to do station approach t plus equals dt. Like that. And that's like float ratio. Like that. So it's going to go from the car's t to the station t. So that's going to give a ratio between 0 and 1, and that's how far away we are from the station. So that isn't quite right like that. it would be nice to know. It would be nice to know the crossing point. In T space of there. Which is here. Which is 0.35. So station radius is 3. Let's try and work that out then. So we have that position in world space. We have the radius. So if we just get the radius length along the line, so this is station we should call it line space for now. So that's what we want to find out, right? So that's the station position. And if we get auto station length, the station length equals path.spline.getPoint 2 times station R, right? Times this step value. Is that right? Where were we? Here we go. No, that's just... So it's divided by path.spline .get length. So that's the station length, station line, the station line space. I won't quite, well, whatever. Station R line space is that, I think. So we get the station radius, and then we divide it by the length of the line. length divided by the length of the line. Okay. So I'm just working all this out, and then I can build something on top of it. Just wait for the car to come back. Okay. So 0.41 is apparently station radius dot length. They get the point on this, and they get divided by the total spline length. So let's just then we'll draw two circles here. Say auto P equals path dot spline get point 0.5 plus station R line space, right? And we'll draw that P. Say float color, let's draw them in white for now. And we'll just draw them small. And minus station R line space. Well, actually, we don't need to even do it there. We'll just do it straight up here. We'll draw one there. So P left. And then P right. Okay, so that's clearly not right. So 0.5 is a station R length divided by path spline length. Because station R. Yes. Yes. Okay. So the station radius is 3. So we need the value of T 3 world units along. The line. Which I think is just that. Actually, There we go. Okay. So we've got the two station. So that's a station P. We want vec2 station approach P. Vec2 station depart P. So that's the approach P. And that's the depart P. What else do we want? We want float station approach T. Float station depart T. Which is this. It's the approach T. No, no. Hang on, let's go back again. So we want station approach T is 0.5 minus station R line space. And that's station approach, oops, and that's station approach T. So that's just like, that is the ratio there. And then station depart T equals 0.5 plus the ratio. Okay, so let's just see if the circles are in the same place. Oh, messed the depart one up. That. Okay, so if we're approaching the station, let's get rid of that now. We're going to do car.t. Well, where are we? If we're approaching the station, I'm just going to say car.t equals bm lerp station approach T to the station T. Well, we can say car.t like that. Let's see what happens there. No good, no good. I know, wrong function. No, that's that. Hang on. So that needs to go from 0 to 1. So let's put back flood approach. Well, station approach T. So that needs another T value. So let's do car.approach T plus equals dt. That's going to be car.approach T. Let's see what happens there. And we're just going to say car.approach T is greater than or equal to 1. Car.approach T equals 0. Was it car.state is equal to monorail car state at station, like that. And we'll say else. Let's see what happens here. Okay, so it's just looping. I'm going to say if not car, I'll say if car dot state is equal to monorail car state traveling. No. If car.state is not equal to, well, okay, if car.state is not equal to monorail car state at station, try that. All right, cool. So what we actually also want to do is this needs to go down by so it needs to be like, let's have a look. It needs to ramp down. So it needs to be eased. So if you look, the ease cheat sheet. So it needs to like ease out sine or something, or ease out cubic. Let's try ease out cubic. BMEs approach T. Do we have ease out cubic? Ease out cubic. Let's see what that looks like. Stick kind of. So let's see what it looks like when it gets in there. Okay. That skipped forward quite a lot. Let's just go back to being linear. Let's just put one car on and have it from the beginning. Is it set to be at the beginning? No, we'll say from the beginning of the spline. Oops. Wrong car. Wrong monorail, sorry. So actually, rather than setting T, why don't we do car.speed equals BM lerp from 4 to 0. Oh. And then we need to do that as well. we need to set T, because T is what drives the car, or moves the circle. Okay, so it goes too quick though. Okay, so I don't think that actually works. Does escape, it does slow down too quick. Try that. Ooh, backwards. Oh, it's not there that I need to times it by 2, sorry. It's here. That's half actually. So doesn't really slow down nicely. Does end up in the middle though. Try ease out cubic again. Try squaring it. See what that looks like. No. Doesn't look terrible. Oh. See, it's not, I don't think it's quite right, because so the way to make this land bang in the center is to do that. We need to go car dot, what is it, station approach T to station T by the approach T. But that just does it linearly. Say else if car.state equals monorail car state at station car.t equals station T. Dot T equals station T. Stop that flicker. All right. So how do we get it to ease into the station? Basically, this value has got to become less every frame. So we'll do car.speed times dt. So we'll minus the car's acceleration. Times step. We'll make sure it's at least going 0.5. You don't need to stop too early. Yeah, maybe we just do that. We could just keep slowing. We could slow the car. Well, the problem with that is it won't slow. It won't slow down. So we could just slow the car down to a crawl. But then if we had bigger stations, that wouldn't look very good. All right, let's go back. So car.speed minus equals dt, right? So we'll just slow the car down. And then I'm going to say car.speed, say if car.speed is less than 0.5, car.speed equals 0.5. And it's got to be car.speed divided by the max speed. See what that looks like. Oh, car.speed equals that. It's not decelerating enough, I don't think. Or maybe it's not getting slow enough. It's decelerating too fast now. It's so bad. So let's just stop drawing these labels for a second. Alright. Let's get a clearer view. That ain't so bad. So what happens if we make the station bigger? That's what I want to know. So station R is set to 3. Let's set it to 6. So that shot it up in velocity. I wonder if we just decelerate it to a minimum velocity. So we could do something like, we could minus the acceleration, minus like, just minus dt. Well, oops. The great thing about this is it will always end up at the station position. So that probably has to be at least station times that. Or even 1 over that. Something over that. So we remove the radius of the station out of the equation. So like if you do like 3 over it, something. Six over it. Let's try 8 over it. And then if we put the station radius back to 3 again. Cool, so if we put it to like 10. I mean, the monorail's not going to have a chance to get fast enough. I mean, that is quite nice. Could just -3 times DTO and then clamp it between 4 and 0.5. Maybe it does need to accelerate, maybe a little bit less dramatically. Or decelerate rather. I think we do kind of want to work on speed though. We could say, we could do car.t plus equals car.speed times step. And then say if car.t is greater than station t, car.t equals car.station t. And then we'll say we're at the station. See what that is like. So it's reducing the acceleration to a minimum amount, moving the car, and if we get past this, if we get past T, we lock it to T. So let's do car dot acceleration. What is acceleration? Whoops. That's the wrong button. It's 1. So let's do float deceleration. We'll say that's a bit stronger. We'll say that's 3. Well, we'll make that a negative number because it's decelerating. And then we'll just clamp it to 0.5 to 4. We'll say that if we're at the station, I'm going to say the car at the station, and then I'm going to say after delay, like 2 seconds, just pass in the car. We'll say car dot state equals monorail car state leaving station. Else if car dot state equals monorail state leaving station, it's basically the same, except when then we say if car dot t is greater than or equal to depart, what do we call this? Station depart t, car dot state equals traveling. So it should stop for 2 seconds and then leave the station. Off. All right. So let's just draw car state above the car. Check it, it's getting back to the travelling state. It's travelling, approaching station, at station, leaving station, travelling. Right, okay. Happy with that. I'm going to take a 2-minute coffee break, and then we want to work on a second car and make sure that it doesn't crash into the first car when it's at the station. We'll be back in 2 minutes. I accidentally made a very strong cup of coffee. Oh well. Alright, so we've got cars travelling in, single cars travelling into the monorail station. And then waiting for a bit, and then travelling on the way again. Okay. So what we're going to do... So we don't need this approach tee. So if you stick another monorail car monorail car on the monorail, we'll just watch what happens. Where is this other car? There isn't another car on there. Oh, there he is. So they will get to points where they'll want to crash into each other. So we do want to prevent that. So what we're going to do is we're just never going to set it to leave the station, basically. Which means that we need to sort this out first, because it only gives it a state if we're in the same room as it. So let's default by saying that the state is traveling for now. Wait for the other one to come. See how it crashes straight on top of it? That is not what we want. So we need to put back in the test for if a car is just behind another car. So we're going to go canvas, so let's do canvas, raw circle, outline in world. And we're going to do... So we'll probably save also a collision P and a collision radius. Well, we'll just say collision P. So it's actually very similar to the stations, just detecting. So it's not collision P, it's collision T really. It's the value in spline space before that we need to work out before where we think we're going to crash. So we're going to do auto collision P equals path spline get point car.t minus car.collision t, just car.collision t. So car.collision t equals car.t minus 0.25 maybe 0.1. A collision T yeah, we need 3 points. We know we need 2 points. No, collision, so yeah, it's set slightly back. So that should be fine. So we'll do canvas dot, we'll just draw a line from the car position to the collision position. Ooh. That's in the other room though. What I want to know, keep it going, it's where the other, we saw the line for the second car. Car T minus 0.1 so it's only from the current room for starters. I want to draw it. Oh, it is there. We'll draw it red. I think it's just drawing on top of the white line. There it is. So we need to make it a little bit longer, so So you can see that red line is its collision. So now what we want to do is we want to say if we get to that point, we need to slow. If we get to so yeah, for all of the cars, cars, if car equals other car, continue. So for all the other cars, we just want to check we're not colliding. So we need to operator equals const monorail car other car. Whoops. Return ID equals other car.id. I'll move that into the source file now. There we go. So for the same car, we don't check. Otherwise, we say if other car.t is less than car.t and other car.t is greater than car.collision t, we're colliding with it. So we could flag it with colliding. Probably do that. Just say and they have to be in the same room. So we have to go if auto other path equals world get monorail path by index other car dot monorail ID other car current path index. Then we could flag it here that it's colliding. So it's if we'll check that, and then this, and path equals other path. Can we actually check a monorail path is equal to another one? Yes. So they have to be on in that region. And on the same path. Now they are colliding. So I think it's just going to be so it's the other car that's colliding. here. So we should make it this car that's colliding. Car.t is greater than equal to... No, it's less than or equal to other car.t. And car.t. So this car is colliding. So if the car's t is less than the other car's t and the car's t is greater than the collision t, then it's colliding. So we don't need to worry about collision p there. And then we're doing all the movement stuff here, so I think we will set on the monorail car just a flag, or just another enum. Enum class E monorail collision state unknown, not colliding. Should say car dot collision state equals E monorail collision state colliding, else car dot collision state is equal monorail collision state not colliding. So I'm going to say if car dot collision state is equal to E monorail collision state colliding, we need to slow the car down to a stop this time. Okay, so to test that, what we might do is also car.collision state, and to test that we don't want to make it so it's travelling. Or we could do it on a key. Key just down, and we'll say I don't know, we'll say E key space, press the space bar, we'll set it to be travelling again. Oh, I've put that in the wrong place. It's actually was here. We don't want to do this delay anymore. Send it to leaving station. That's what we're doing. If we press the space key now. So it's at the station, it's not colliding. We'll wait for the other one to come. So he stops. If I press space, this guy goes on. And he starts again. And he's now at the station. And wait for the other guy to come along. Awesome. Awesome, awesome. So let's put another monorail. Let's put 3 on. Dynamic. T is dynamic between 0 and 1. So we're going to put 3 on random locations on the monorail. Okay. They did crash there. So there's a bit of logic problem there. So if it's colliding, if car.collision state equals, well, if car.collision state is not equal to E monorail collision state colliding, continue. Now if it is equal to colliding, we continue. Sorry. It's only no, that's not right. That's not right. Else if car, well, it's because it's saying it's colliding with a car and then the next car is not colliding with that. So maybe it's just a break here. Let's try that. So I'm going again. Which of this other one comes back? All right. So let's put on a bunch of them now. Let's put 6 on. See, they're crashing there because they're so it crashed into there because it didn't have enough space to stop. If we don't put monorail stations too close to the start of curves, that might be alright. So we need the actual amount of deceleration if the colliding needs to be dependent on the distance. We need to really ramp up the amount of deceleration if they're really close together. We really want to guarantee they don't crash into each other. So we want like the collision distance. So we want to say like car.collision d equals other car dot t minus car dot t, like that. So when they approach the same t, that approaches 0. And maybe minus a little bit, so it's actually behind the car. And then that has got to be divided by car.collision d. See what that looks like. Might make them stop really fast, that's the only thing. We still have the problem with the end of the curve because it doesn't kind of work for the end of the curve. A car got put on the curve again in front of the other car. Yeah, I think what we'll do is we'll just make sure that when we're building out the actual monorail, the stations aren't too far, aren't too close to the beginning and end of the curves. So we'll probably put a monorail car in each station. We actually... See, that's only happening there because it's too close. Could make the deceleration faster. Could say, if we're in a situation where we're colliding, we could have 2 times deceleration. Yeah. Okay. I think I'm just happy without having 2 times deceleration. And we don't need to put 3 cars back on. Obviously that was too many cars for that tiny little path. Okay, cool. So I'm gonna say 1 second. We'll go back to the notes. I'm going to say car movement. We're there. As far as I want to take it now anyway. So we want to add these so I've just hard coded this monorail station in. We want to be able to add them with the editor. Rosto Cotiola, how's it going? Welcome back. All right, so what do we need from all? What do we need this? So that's station T. That's where the station is. That's the radius in world space of the station. Alive. Me too. The station position. So it's going through each path and just drawing the path. And this is the monorails in the system. Good, yeah. So, do we have anything like a monorail station? No. So, struct monorail station, and we're going to do put those. You're lost. What? On the code or in life? I was there, wasn't I? In life, yeah. In general. I think everybody's lost in some way or at some time. So, enum class, monorail station, and we're just going to call this Morley's monorail station. We need at least two, so we're going to call this Monty's monorail station. Yeah. Yeah, the monorail's gonna be something where you can just catch it and chill out. And ride around the space station. Or you can use it as fast travel. And it's going to be a cool way to get the player to see places that they can't currently travel to and be like, oh, what's that? Because you can travel past it on the monorail, but you can't get off until, you know, then later in the game you can end up there. Alright, Morley's monorail station and Monty's monorail station. So we've got two monorail stations. U64 ID. I need to spell monorail right. My brain just can't spell monorail right. Type or kind. Kind unknown. Me neither. Thank God for Google. Yeah, spelling's terrible. My spelling's terrible. Okay. Before Google, you've had to carry a dictionary around with you, or just spell everything wrong. I probably would have just spelled everything wrong all the time. So it has an ID and it has a kind. We want U64 get monorail station ID. E monorail station kind. So that, ooh, we don't want it there. No, I don't care either. Back back in the day, people just used to spell it how they wanted. At least in England, you could go from town to town and everything would be spelled different. They know because people wrote things down and they spelled everything differently, everything phonetically. So that is the hash 64 of the enum name of kind. Yeah. So my hometown has its own accent. And if you go to a town 15 miles up the road, not even that, like 12 miles up the road, it's completely different up the coast. Like you can tell, if you in your own area, you can tell which town a person comes from by their accent. Yeah. Yeah, it's crazy. Monorail station kind. Okay, so we have the monorail station kind. So what do we actually need from all this stuff? We need the approach T and the depart T. Do we need to store them, or are we just working them out? We're just working them out. So that can be local. The positions are for literally just drawing them. So the T is where it is on the curve, and the radius is in world space for some reason. So the position is for drawing. We don't need that, but we need it for working out whether we're in it or not. But the main thing it needs is that could be hard-coded valid. Station T and station R. So T and R is in world space. It could be in T space. So we're going to go float T. And then, to be fair, we could probably just hard code, but R is based on the name of the station. We just need to know where it is on the curve. So I think those are the only things we need. Operators in. Can't type today. Kind is equal to other kind. All right. And then we probably want a constructor. We just need to, we don't even need a constructor actually. We can we'll say this comes from the save file. No, we won't. We'll say it's a U32 for now. We'll put it in a save file. We'll put it, make sure so it's a save from a save file. And then we want to create a monorail station for every different type of monorail. But we're just not going to put where we're putting it. Oh, yeah, so we also want the path ID. But the monorail ID, we already have a monorail ID, which is 0. In the game board content, so we have monorail stuff on monorail path. We have IDs. Oh, that's just a path. In the world, what do we do about monorails? World monorail path. World monorail. We have an ID for the world monorail there. Okay. So we probably need the monorail ID. And the monorail, the path ID. What monorail it belongs to and what path it's on. And they can get set when we load the game. They can come from the editor. These can get set in a constructor. ID is ID. Kind is kind. And then we want an array of monorail stations. And when we launch the game, we just want to do a similar thing to what I am doing here. So stations empty, and then 4 to, I'm going to go from 1 to the enum count of e-monorail station kind, and then we're just going to go stations in place, static cast e-monorail station kind so that will create a bunch of monorail stations. Station departee undeclared identifier. So we do need to cache out station departee. Do we? Why? Just to know whether we've left the station or not. Okay, well we'll just cache out station departee then. This is all going to get removed anyway. Ah. Okay. So we need to do this constructor. Doesn't need its ID. We did the constructor wrong. Its ID is get monorail ID, get monorail station ID, kind. Kind is kind. Is the station. So this is that path. We probably need to be able to add more than one station per path. Because my idea is it's really one path per room. So how are we going to do this? We need to do something like this plus button here so we can add stations in. All right. So where's this? This is triggers left. So this is tick. Well, not an editor window. Game board editor. Tick left panel. Trigger mode. Where do we do this plus? Conditions. Conditions is the same. It's events. It's add event. We have events. Okay. So tick monorail. Tick left panel. Path mode. It's here for a board monorail path. So we want to go canvas draw separator. Maybe we do canvas draw separator stations. And then we're going to do if that. We're going to just say if canvas draw button add station e icon glyph plus icon okay, so let's see if we have a plus icon. So we need the color. Colors, do we have colors? Is that really how it works? We have to pick the color. Where are we? Style white. Do we have style? No. Auto style equals editor. Get style. How do we get the style? Get editor. Style. How do I get the style? Style. Get editor colors. So they're actually not style, they are colors. Got it twice as well. That's alright. Colors. Okay. Name things properly. White. Alright, so if we do this and we click that now, we have stations, and in there's a plus icon. Doesn't do anything. See, this is also a bug, a little visual bug. It should be in the middle. And it's only not in the middle because, well, I don't know why it's not in the middle. It happens for all of them though. You only go into the middle as soon as you start drawing something inside this group. Maybe we should fix it because it's been around for ages. So it's there now. It's in the middle now. Let's figure out why. Let's just spend a little 5 minutes now just figuring out why that is like that, not in the middle. Gets next button bounds. I can flow left to right. So next P to X. Because it has nothing to do with next P. Okay, so that's because it's not. It doesn't check if it needs to be drawn in the middle. Next P to X is being set earlier. Flow is left right. I mean, it is technically. Yeah, I don't think it's worth fixing. It's just a button in the editor. So nothing happens when we press that button. So the monorail, board monorail path needs struct board monorail station. Now the station needs to come in from the editor as well. It needs to come in from the game even. So we're going to have U64 ID. And all we want to suppose do now, well, and then we'll say float T. T is the distance on the curve. We know what monorail it's in. No, we haven't actually allowed separate monorails in the editor. We do need to work on that as well. Yeah, we'll work on that as well. So that's just the ID of the station and the position along the spline that the station is on. And then the monorail path needs an array of them, monorail stations. We need to actually add this into the serialization. Whoops. So a monorail station is trivially binary serializable. It's under transform, under true type, and we need to reflect it. ID and T. Should maybe call it like position T. Spline T. Might be better. rather than just T, especially if this is going in a data file. Okay. Now that means that this stops being trivially binary or serializable, which means we need to implement a writer, a binary serializer for it. So the path has type source dest path.stations. Same for the read. Okay, so assuming that builds, you have a space now to put stations in. Does build. Okay, so let's do where are we? Game board editor. Tick left panel for monorail path. So this is, if we had a station, it's monorail. Where is it? What we call this? It's path stations in place. Like that. So just make a station. And then we need to display them. So put it above. For auto station in path stations. Okay, so let's have a quick look at the trigger one again. It's UI scope region. So we'll do this. For S in path stations. UI scope region. Scope region. Canvas. S will probably do. And then we want to go auto station equals path stations S. And then we're going to do canvas, draw text box. It's not going to be a text box, it's probably going to be a combo box. Station ID. Combo box eventually, but we can't draw it yet. Station.id. And then canvas, draw text box. Spline T. Station spline T, and then we want to min max that between 0 and 1. Check that builds. No, we need a delta as well, I think. Delta 0.1, so I'll have 100 different. Obviously that delta is, it's going to change with the length of the spline. Yeah. Yeah, we need to work out that delta really. It needs to be fixed, and a fixed amount independent of the length of the spline. Yeah. Alright, so let's see if we have it. So we can go like this, and then we can add a station. There we go. See that? Yeah. 0.01 means 100 points a station could be on. I think that delta's kind of got to get normalised depending on the length of the spline. Divided by path.spline. Where does the spline live? Source path. Light level path. So what do we have here? A board monorail path. What do we have here? Do we even have path? Board monorail path. So where is this? So maybe it has to pass in this path as well. It's okay, we can just get it like that. So we can't call that path. We have to call this board path. Okay, so this now is divided by board path. It's not there. We don't have content either. Okay, we need all this. So now we can divide it by board path, spline, get length. So I'll make that delta smaller for bigger, for longer paths. Hopefully that should normalise it out. Look at that, we can move that. So if we click and drag over, it picks it up. Does that happen on like a trigger? No. Alright, I need to fix that. Let's fix that. So tick board panel paths mode. So if canvas has drag, so is it saying that the canvas has to have drag? The canvas shouldn't have drag. Where do we move the entire spline? Selecting it, drag delta. Okay. I'm going to say, if not canvas that has drag, Drag delta. We'll reset it. If we don't have drag, we'll reset it. So double click, can drag it around. Can we drag a point and can we drag it off? We can. We do this. There we go, it doesn't pick it up anymore. Okay. So if we add a station, yeah, it doesn't pick it up. Good. Right, so we need to draw. Seeing as we're here, we need to actually draw all the stations on the path. Now then, we only probably want to draw them if we are not focused. For auto station, path.stations. Oh, if it's a monorail. If auto monorail or monorail. Now, actually, do we want to even it? Do we want to go for a different function here? Yeah, I think we'll do this. We'll say for each type, get 4 path types. If auto data equals, we need to pass the path as well. Path try and wrap. Well, we need auto. We need using t equals standard decay t of the type of x. And if it is a t, then we're just going to draw it. It's the t. Okay. So we're going to do this paths mode, and then we're going to draw odd monorail path. Draw board panel. What is it? Tick board panel. Paths mode. Game board. Editor. Canvas. Data. Like that. And then we need to get the path out just like we did in the left panel. And then we're going to go no, we need to actually pass the path this time. So this is board path, and then monorail path. Let's say board path and monorail path. So this is path. Check that builds. Nope. Okay. So we need to capture all this stuff. Game board. Editor. Canvas. Path. Alright, cool. So we're just going to go for auto station in monorail path stations. Auto P equals board path spline get position get point station T spline T. And then we're just going to draw probably, we'll just draw a circle for now. So canvas, draw circle, circle in world P, pixels to world 8. Look, we'll do right white, Z order, canvas dot get Z order. Auto Z order equals canvas dot get Z order, and that is just Z order dot get Z. Easy layer is a circle. So there isn't a circle. If we draw a circle, what are we actually doing? RGB XY and world. RGB XY and world. So it's the same as quad. So we can go in the same shader as quad. Circle. Circle. Right, check that builds. So that in theory draws the circle along the path. Segment count. I always miss out segment count. 16. That draws the station as a dot along the path. This build, we changed the Z order, which is used by all of the editors and stuff, which might add to the build. I can't remember what else we changed. And then, assuming now we can move the stations along the path, that means we can set the positions of the stations. The next thing we need to do is get to the names of the stations, so we can populate a combo box and select what the station is called. And as far as the editor is concerned, that's probably all we need, at least for now. So add a station. There's that white dot now, and if I move this, you can see it going along. So we can set the position of the station on the spline. So let's make a bit more of a complicated spline. It could be crazy like this. Yeah, I need to fix the editor as well, so it allows you to drag off the screen. Cool. Alright, so now let's just save that. And see if we can load that back up. So it was 5449. So we'll run the game again. I'll run the editor again. Just check that gets loaded back up. Yeah, that's right. 5449, cool. So also I think I don't want to draw any, so when I'm dragging here, I don't know if I really want to draw. Yeah, that's annoying. I don't know if I really want to draw all this debug out. Well, not debug output, but all these handles. Another thing I do want to actually check is if I add in another spline and it's a lot shorter. Add a station. I want to check that the dots move the same velocity, even though the splines are different lengths. Yeah, they do. That's fine. That's good. So I want to, whenever the canvas is dragging, we don't want to draw these control points. Tick board panel paths mode. So if not canvas has drag, so where are we drawing them? If not canvas has drag. So we are doing it if we're not drawing them if the canvas that we're drawing the spline on has drag, but if the canvas, the left canvas has drag, we're still drawing them. So it's the window drag, really. Does the window have a drag? Has drag. And what does that do? That draws all the control points. Where do we draw the line? So this is window as well. So as long as that's if the entire window doesn't have drag, we don't draw it, rather than just the canvas that we're drawing the spline on. Check that works. So if we click it, if we drag a control point, it turns them off. And if we drag that, it turns them off as well. Good. Yeah, that's annoying. If you hit the side of the screen, you can't drag anymore. It's a minor annoyance. It's not worth, I don't think, re-implementing or looking at how that works. Fix it. How do you do it? It needs to be based on the delta again. Yeah. I don't know. Alright, so now we're actually drawing it. So now we need so in the left panel, whoops, not there. Path mode left panel for monorails. Splines can never be 0 length. I mean, we can just say what the max. Say they can be never be 0 length, but okay. So we need to get this. This isn't a text box with station ID. This is a combo box with station name. Now, I can't just use the enumeration for station name because this editor stuff cannot see the game library. So you need to interface through the game class. Like here. So we need TArray, view string view, get monorail station names. Either that or we call into the game to draw it. Let's have a look. Where are we? Initialize. We've got UI game event render, dialog node renderer, dialog choice renderer. We could make a monorail renderer. Or we could just return the names of the monorails. Let's return the names of the monorails, it's fine. Return, so what would it be? Enum W names. Get views. So it's num W names, e monorail station kind, get views. I think it's just that. Okay. So we need to include the monorail controller. And then in the game board editor here, we need to go auto stations equals get game, get monorail station names, and then canvas draw combo box station, and the selected item which is a string. Well, first let's just make a string. Oops. Stations 0. So we're going to do this here. If stations, no stations, we can't do this. So that's selected item and that's stations. Let's see. That's not gonna work. I mean, it might work. No, probably would have been fine. Not what we want. Some water. Okay, so let's just see then if we have a combo box of stations. Morley's monorail station and Monty's monorail station. Monty's monorail station, spelt wrong. Alright, cool. So let's go back to the monorail controller and just change that. So this here is the station ID, right? So I think what I might call this is path station. Now we have to make sure that the path station ID is not going to there's enough stations. So I'm going to say if path station.id is greater than or equal to stations.getCount, path.station.id is 0, it will reset it to unknown. So if you delete station from the code, it sets it what all the stations that used to be that station you deleted gets set to 0. Not quite though. So I wonder then if we mark this as save file U32, this just reminds me that this is fixed in data and I should only append to it, because these are just integers, not enums. So obviously if I change the enum, all the integers go like out of sync. So I use that little tag there to say, well, this is in a save file, so don't mess with it, just add to it. Alright, so now in theory we should be able to say this is a oh no, because I'm not setting. I'm not setting it. So if auto result is that, we want to go path station.id equals stations.index of result new value. Result new value, and that'll set the path station ID to be whatever the result of the combo box was. Right. So I'm going to set it to be Morley's Monorail Station. I'm going to save. I'm going to try and load that back up again. There you go, Morley's Monorail Station. So if we set that to be like here, and then we add another one there, and that can be Monty's Monorail Station. And then we just, yeah, so when you move these as well, they do move the stations. Because they're based on T. So if we want to fix that, we need to actually store the world position and then calculate the new value of T every time we move. Chances are we might make a little adjustment to the path of the monorail, and we don't want all of the stations to move. So we shouldn't store t, we should store the distance. Well, we can't store the distance because that's going to change. We need to store the world position. And then try and match it. So we need to get the closest world position on the line. Right. So we can't... Ooh. You store the world position, but then move the entire monorail. Can't do that either. So that works if you move. Well, it's drawing it a little bit weirdly, but that works. You move the entire monorail, the position is... If we move this here, it moves all of the stations. So how do we represent? We do have to store them as t, as the distance along the spline, unless we are changing the control points. Okay, so this data remains the same. What it is on the board, on the monorail board. So basically we need to know if we need a hash of all of the control points. Is it all of the control points? It's all of the we need a hash of all the control points, like relative to the first control point, I think. Not just the positions of the control points, but the local positions of the control points. So I'm going to store that. U64 control point hash like this. And then the station so I wonder if you should store that in the path generally. In the board path. Yeah, let's store that in the board path. That's useful in general. Not just for monorails. Oops. Control point hash. Alright. But the stations do need it in, because they're going to use... Well, they... Yeah, because it needs to do it with all of the stations. Yeah. So, usage for... So they both need to store it. So control point hash, path.control point hash. So now, when we tick in the paths mode, there we go, game board editor. So whenever we've changed, so it's whenever we rebuild the points here. So we're doing it here as well. I'll just set it to be 0, which is fine. So we want to go for auto CP control points. So we're going to say if control points, we're going to go auto first, P0 plus control points first, right? Path control point, path spline control points. We have control points, yeah, first. And then we want to go path dot control point hash equals hash 64 path dot control point hash CP minus P0, I think. So that'll generate a new hash whenever they've changed. And the hash will be the same. So we need to actually set this to be 0 or something. A known number. So that means that the hash will only change when the control points change relative to each other, not when they change. No, that's not correct either, because we could just work it out every single time. We'll just do... what do we want to do? Yeah, I think all we'll do is, rather than... we'll definitely want to store it in the monorail path. I don't think... we won't store it here. So we're going to say auto hash equals board path, or hash 64 board path spline get control points. So we'll just hash the control points, and then we're going to say if monorail path control point hash is not equal to the hash, I'm going to set it equal to the hash, and then we need to rebuild what t is. What spline t is. Which means we need to also store the world position. So here's the thing, if we just move it, spline t has to remain the same. If we remove any control points, spline t has to be updated. That's all right, because we can just say that we're moving it, we're moving the entire spline and not update it. Yeah. So if we're just moving, this is the state where we're moving the entire spline. So we could just say, yeah, remove the entire spline, you don't need to do it. So we still need to know that we remove the control points. So if we've got different control points, we need to basically so when we set spline T on the left panel, which is here, we need to recalculate the world position. So spline T, we're going to say vec2 world P. So I'm going to say if it changes, we're going to say path station world P equals board path spline, get point, path station, spline T, right? And then when we tick the board panel, for the monorail, we actually just want station position. Is it world P? Station world P. And then we need to recalculate the world P now. As close as we can. Getting it onto the spline as close as we can. Alright, let's take a 2-minute break and get a cup of coffee while this is building. It won't be long. Alright then. So now we have the monorail stations locked in space, but if we move the path it won't change. So it'll change if we move this. But then if we move the path it won't change. We just need to lock them. We just need, when we do move the path, which is in this situation. So if we change this situation, we need to recalculate. We need to go through the spline and get the closest position on the spline to the path. So that is, do we have a function for that? Find closest edge to point. Whoops. Find closest edge to point. Points begin, points end, point. And it returns an optional edge. And what is an edge? 2 points in the distance. Okay. So we can get the smallest distance. Which is what that does. Okay, we'll do that. So, the point is the station world position. If auto result equals geometry, find closest edge to point. The points are board path spline, get points, so this is just points dot begin, points dot end, station world P. Check that builds. And then I presume we just pick them. We have to pick, we can't pick the middle. So we got result. We got 2 points. The middle might not land on the curve. So we have to pick one of the points. Okay, the closest point. So auto d0 equals station dot world P. Distance doesn't like world P. Distance squared. Result. What is it? Points. Result. P0. And then D1 is the distance to P1. I'm just going to say D0 is less than or equal to D1, else. I'm just going to say station dot world P equals points result P0. And then we have to set the spline T as well. And the spline T is station.spline T. Check it's all builds first because IntelliSense is not working. So station.spline T is we need to get or path spline we need to get the compound lengths. So in spline, we need to get the compound lengths. Array float, get compound lengths. Auto lengths equals board spline get compound lengths. The spline T is spline is compound length, or it's lengths result P0 divided by board spline. Board, what are we calling this? Board path spline get length. And I would think we should probably just do board.spline get point station spline T like that. Actually P0. That's P1. So I might say auto spline length. Spline length equals board path dot spline dot get length. Right, let's see if that, it's not going to be exactly, not going to keep the stations in exactly the same place, but it will try its best. I've got D1 is less than D1 there. Does guarantee that the world position of the station is always on the spline though, which is the most important thing. And this doesn't work if we move the whole spline. If we move the whole spline, we just need to recreate the world points. All right. Let's put that back here. So if we move this now, it's trying its best. Is it? It's trying its best. So if we move this, you see it doesn't actually move the stations, which is perfect. That is what I was after. It's a little bit weird that it resets it to 0. It's trying to keep it in the same place. I wonder if that's because it's not changing it. It should be changing it. So why is it jumping to? Because it's not finding a result, maybe. No, that wouldn't jump it to 0. So we put that one there. So if we move this control point, it doesn't move that station up here, which is the main thing we were going for. I would think though, it should also be able to keep it a bit better located, even if locally here. Like there, it should be able to find. So maybe we could do the center there now. So we could do plus lengths result P1 divided by 2 divided by spline length. Put that on 0.2 and then save it. Okay. It works if I do it quickly. Whoa. Sometimes it doesn't work at all. It is working a bit though. It's definitely working. When it's not local to a control point. So if I was to add like control points up here and move them around, it doesn't change. But then if I do want to change them a little bit here, I can do that. Can't be doing that though. So why is it doing that? That is very strange. That is very strange. Why are we doing this swap? Oh, we're just making sure that they're in the right order. Wrote that a long time ago. Yeah, it'd be hard for me to actually catch the debug case. Where it flips around. But at least we can alter the path and not change the stations that are directly on top of the path that we're altering. Like they are directly on top, so they have to get changed. I do wonder why. Like if I... Ooh. Let's delete some of these control points. So if I just have 3 like that. Like that should, in theory, it does when it's, if you move it fast. That should in theory be able to hold its position rather than move with the line. So let's just draw where these are. Let's do canvas, draw line in world. Points, result P1 naught, points, result P1, do it green. So I wonder if we might do this separately. I wonder if we might do this a bit different. There's a better way to do this, where we could just set the station to be at the end of the spline. Yeah, that might be better. So then we create a new spline. And we just connect it like this. And the endpoints can become stations. And then I can move these whichever way I want. Obviously, I'd have to make sure that they looked smooth. Yeah, that is much better. And the endpoints can become stations. That means slightly changing art movement though. The car movement, because the cars don't know about opposing stations. Mind you, how many are we gonna have really? Probably only gonna have one in each room. We obviously need to only gonna have one station in each room really. So we could either have two paths and then where they intersect is the station, or we just have one station per room and we put it on just one path per room. Yeah, I think we'll have one path per room. We just get rid of all this stuff. Yeah, I don't know. We do get rid of all this stuff anyway. The station's world P we don't really need anymore. Auto P equals board path spline get position get point station spline T, and that can be P. See where else we need to rebuild. Yeah, that can go away. Hmm. Yeah, I have to think about how I want this to work, really. I'm not sure. I might have done it the wrong way around. I might have needed to build stations first. So you basically do something like this is a monorail station, and then you have a path, and that would be displaying, and then you would like connect it to the monorail station and have another path and connect it to the monorail station. See if we can just show triggers. So say that was like that, and that would be the station. And then if you were to say that was a monorail path, it would know that that's a station because it's intersecting that trigger. I think that's how I might do it. I might come back at this tomorrow and redo it, which means redoing car movement a little bit. So I'll uncheck that because I have to go back and get the car movement correct. So this would be like a trigger ID, or we could say it's like Morley's monorail station, and then this we could mark up as Morley's monorail station. Source station, desk station. And if desk station this needs more thought, because we could have something like path into station, station out to path. So I think possibly as well we could select these control points, and you could go in the control point. Well, no. Yeah. All right. We'll do something like that. I'll save this, and then we will work on it tomorrow. But I'm gonna have to head off because I need to finish early because I don't have a car. I'll walk home. So I'll see you later. See you tomorrow. About 10.